This tutorial is on balancing chemical equations. The reason why you must balance chemical equations is to show the law of conservation of mass. This shows that the atoms are only being rearranged. Atoms are not being destroyed. Atoms are not being created. They're not being changed. They're only being rearranged into new combinations of substances. To give you a quick introduction to balancing chemical equations, imagine this equation. Hydrogen peroxide in the presence of UV light breaks down into water and oxygen. Again, you have to have the same kinds of numbers of atoms on both sides. So the blue spheres represent oxygens. So the reactant side, we have 2 oxygens. But on the product side, we have 3 oxygens. 1, 2, 3. On the reactant side, we've got 2 hydrogens. On the product side, we've got 2 hydrogens. So right now, the hydrogens are balanced, but the oxygens are not. And so how do we balance this? Well, note on the reactant side, since it's H2O2, the hydrogens and oxygens must be always even. No matter what number I put in front there, you always have to have an even number. So it's this oxygen that is making it odd. So I'm going to start by doubling the number of water molecules. So now I've got 2 water molecules. And those 2 water molecules are now going to give me 4 oxygens and 4 hydrogens on the product side. So 1, 2, 3, 4 oxygens. 1, 2, 3, 4 hydrogens. And to get the same number of hydrogens and oxygens on the reactant side, I'm going to double the hydrogen peroxide. So now we've got 2 hydrogen peroxides. That's going to double the number of oxygens and the hydrogens. So now we've got 1, 2, 3, 4 oxygens and 1, 2, 3, 4 hydrogens. So now we have the same kinds of numbers of atoms on the reactant side as the product side. Therefore, the mass is going to be the same on both sides. We have the same kinds of numbers of atoms. They've just rearranged themselves from being hydrogen peroxide to becoming water and oxygen. And again, that's what chemical reactions are, the rearranging of elements or atoms into new compounds. So to balance chemical reactions, make sure you write the correct skeleton equation first. And then it's always a good idea to balance the most complex substance first, the one that has the most atoms and most types of elements in it. Balance the single elements last because you can change those without changing anything else. And you never balance with subscripts, only coefficients, the numbers that you put in front of the compounds. So glucose combines with oxygen to form carbon dioxide and water. First thing you want to do is write the correct skeleton equation. If you can ever not balance an equation, it's probably because you've written a reactant or product incorrectly. So this is the correct formula for glucose. Oxygen, remember, is diatomic, and a combustion reaction is going to form carbon dioxide and water. So let's balance the glucose first. Again, that's the most complex. It's got the most parts to it and the most different kinds of elements. So on the reactant side, we have 6 carbons. So to get 6 carbons on the product side, I'm going to put a 6 there. 6 CO2s will give me 6 carbons. So I balance the carbons. Next, I'm going to go to the hydrogens. I've got 12 hydrogens on the reactant side. So to get 12 on the product side, again, I can't just make this number a 12 because water is not H12O, it's H2O. So you only balance with the coefficients, the numbers you put in front. So by putting a 6 there, 6 times 2 gives me 12 hydrogens on the product side. And now I've got 18 oxygen atoms on the product side. 6 times 2 is going to give me 12 there. 6 times 1 is going to give me 6 more there. So it adds up to 18. And right now we have 8 oxygen molecules or atoms already. And so the way to phrase the question, I have 6 here, How many more do I need to get 18? I need 12 more. So if I put a 6 there, that's going to give me 12 here, 6 here, 18 there. Now it is a balanced chemical reaction. I have the same kinds and numbers of atoms on both sides of the equation. Go through a couple more. Magnesium hydrogen carbonate, when heated, forms magnesium oxide, water, and carbon dioxide. Again, make sure you get the skeleton equation correct. If I thought magnesium hydrogen carbonate had this chemical formula, this would be an impossible reaction to balance. So again, make sure you've got all your reactants written correctly. And so right now we've got 1 magnesium on the reactant side, 1 magnesium on the product side. They are balanced. You've got 2 hydrogens on the reactant side, and you've got 2 hydrogens on the product side, so they're balanced. You've got 2 carbons on the reactant side. Again, this whole thing has to be multiplied by 2, and you've only got 1 on the product side, so we need to put a 2 over there to get 2 carbons on the product side. And note, by putting a 2 there, I have not changed the magnesium or the hydrogens, so these remain balanced. By putting a 2 there, that is going to really balance the entire reaction. I've got 6 oxygens on the reactant side, and 1, 2, and 4 more make 6 oxygens on the product side. So now we have the same kinds of numbers of atoms on both sides. That is a balanced chemical reaction. A spark is added to a mixture of hexane gas and air. And again, you need to recognize that this is a combustion reaction. In the air, there's going to be oxygen, and when oxygen combines with a hydrocarbon, it's going to produce carbon dioxide and water. Right now, we've got 6 carbons on the reactant side, and so I need to put a 6 here to get 6 carbons on the product side. I've got 14 hydrogens on the reactant side. I need to put a 7 here because 7 times 2 will give me 14 hydrogens on the product side. But now we're going to run into an odd-even problem. In terms of oxygens on the product side, we have 6 times 2, which is going to give us 12, plus 7 times 1, which is going to give us 7 more. That gives us 19. That's an odd number, and oxygens can only ever be even on the reactant side. When that happens, double everything that you balanced to that point. So I'm going to put a 2 here, and that's going to make this 12. I then need to double this to 12 to balance the carbons on the product side. And I need to change this to a 14 because I changed this to 28, and now 14 times 2 is going to give me 28 on the product side. And my 19 just became 38. 12 times 2 is going to give me 24. 14 times 1 gives me 14. 24 and 14 make 38. And now I can put a 19 there because 19 times 2 is 38. And now we have the same kinds of numbers of atoms on the both sides. That happens a lot with combustion reactions where you run into that odd even, and that's just something to generally watch out for all balancing equations.